Our topic is quantum computing in finance. So, what is quantum computing? Quantum computing is different from classical computing. As classical computing are using bits, quantum computing is using qubits. Superposition is really important. It means that the qubits can represent both 1 and 0. Just like shooting a cat, you don't know whether the cat is alive or dead until you open the box. You won't know the state of the qubit until you open it. Entanglement means that each of the qubits react to a change in the other state instantaneously, so you only need to measure one of them and you will know the state of the others. So that makes quantum computing very efficient, as it can do all the calculations at the same time.
Finance can be defined as the science of money management, a discipline almost as old as civilization itself. In its deeper nature, finance deals with uncertainty. Concepts such as interest rates and dividends arise from the impossibility of predicting the future profits resulting from an investment. Imagine giving a loan to a customer. We don't know for sure if this customer is going to repay us or if he's going to pocket the money and disappear. Financial players must continuously balance the risk of losses from bad investments with the risk of going out of business by not getting enough profits from good investments. This is a tough situation where bigger profits result from analyzing a situation faster and in more detail. As you may guess, this environment is perfect for quantum computers.
The business model and technology. JP Morgan will begin exploring the potential of quantum computing and how it might be applied to trading strategies, portfolio optimization, asset pricing, and risk analysis with tech giant IBM. IBM believes one of the potential applications of quantum technology could be to wrangle huge amounts of financial data to better assess risk. The firm will have access to IBM's 20-qubit quantum computing system over the cloud, which is capable of exploring possible solutions for narrow optimization problems and eventually have access to its next-generation 50-qubit system over the cloud. Quantum computers could provide exponentially more computing power for solving certain types of problems that require the use of complex algorithmic models to determine a likely outcome.
Application of quantum computing in finance. A big area that quantum computing will have an impact on is in quantum optimization. Optimization problems are at the core of many financial problems. For example, portfolio optimization, which is selecting the best assets to invest in to balance risk with expected returns, is very difficult for classical computers to accomplish. So, quantum annealing, a quantum mechanical metaheuristic, to solve optimization and sampling problems can provide solutions for things like optimal trading trajectory, arbitrage, optimal feature selection in credit scoring, and much more. Another big thing is quantum amplitude estimation, or QAE, and Monte Carlo simulations. So the Monte Carlo simulations are used to model the probability of different outcomes in a process that is hard to predict due to the intervention of other random variables. In finance, it can be used to simulate uncertainties affecting things like stocks, portfolios, or options. Thus, Monte Carlo is very useful to things like portfolio evaluation, personal finance planning, risk evaluation, and derivatives pricing. The problem with these simulations is that to get a result with very small error, or to get the most probable outcome of a wide distribution, the number of simulations that need to be performed gets extremely large, and some of the simulations take a long time to perform, like stock market simulations, which are day-long simulations. This is where quantum amplitude estimation, or QAE, comes in handy. It can sample probability distributions a lot faster than classical computers can, creating a lot more efficiency. Now a brief overview of the industries that quantum computing have a big impact on. So one of them is in traffic management in the automotive industry. So current traffic models are hindered by the fact that they can only process so many tasks at a time, and traffic has a lot of moving parts to it. In traffic optimization, which quantum computing will do, there will be algorithms that can process and optimize more data quicker and more accurately. And this can help in the eventual deployment of autonomous cars, as algorithms can then put them on the quickest path and keep congestion to a minimum. Another big area is in chemistry. So a few examples of where quantum computing can help is to produce a more efficient and greener fertilizer that will be better for the planet, creating superconductors, more efficient lithium-ion batteries, and also in the production of medicine and materials, as quantum computing can help untangle the complexity of molecular and chemical interactions leading to the discovery of these new medicines and materials.